Alright, welcome to Lesson 16's checkpoint questions. I'm going to answer first if there's any proofs, and then I would go through other questions. So I'm not seeing any proof-based questions, so we'll just start with question 10. The figure shows triangle ABC and its image after a transformation, triangle A prime, B prime, C prime. The figure shows that length that the length of AB is equal to 8.1, the length of A prime B prime is equal to 5.1, the length of AC is equal to 6.7, the length of A prime C prime is equal to 4.2, the length of BC is equal to 7.1, the length of B prime C prime is equal to 4.5, and segment AB is parallel to segment A prime B prime, segment BC is parallel to segment B prime C prime, and AC, A prime, and C prime all lie on the same line, which is demonstrated in this diagram. And now they want to know if the transformation represents a dilation. So we need to compare corresponding sides and check their ratios. And now how we can identify corresponding sides is the order in which the triangle is named. So AB, A to B, will correspond to A prime, B prime, because those are the first two vertices listed in the name. So we're going to find the scale factor for the ratio of A, B compared to A prime, B prime. We also need to find the scale factor for the other two corresponding sides. So then in naming it, it goes triangle ABC. So from B to C, we need to find its corresponding side, and in the naming of it, it says A prime, B prime, C prime. So it would go B prime, C prime, since it's the second vertex to the third vertex. So we're going to find another scale factor for the sides, corresponding sides of BC compared to B prime, C prime. And the last remaining corresponding sides is from C to A. And we're going to find that scale factor, the ratio from C to A, and compare it to the corresponding side of C prime, A prime, because it's the third vertex to the first vertex. Now we're finding the distances of those. So we have, if there is a dilation, then all of our scale factors will come out to be the same number. So the length of AB is 8.1. The length of A prime, B prime is 5.1. And I'm going to use the calculator and just do 8.1 divided by 5.1. Find out what that number is. And it's 1.588. Continue. And now we're going to find the scale factor for the corresponding sides BC and B prime, C prime. BC's length was 7.1, and its corresponding side B prime, C prime is 4.5. And that's going to come down to 1.57. And I can stop right here because these two scale factors do not match. So since they do not match, it is not a dilation. Question 9. Choose the statement that best describes dilation. A transformation that produces an image of the same shape but of a different size. A transformation that maps every point to a new point that is equidistant from a center line. A transformation that produces an image of the same size but different orientation. A transformation that maps every point to a new point that is the same distance and same direction. Okay, dilation means it becomes bigger or smaller. So a transformation that produces an image of the same shape but of a different size is a good description of a dilation, but isn't the best description. So the other one that might be better is a transformation that maps every point to a new point that is equidistant from a center line. So how we could determine this is if you were to have your lesson, the level up in a different one, you notice right here it has key terms. If you click on the key terms, you can click on dilation, and it says a transformation that maps every point on a line segment to a corresponding point on a parallel segment if the center of dilation is not on the segment and the scale factor does not equal 0. So since it was not talking about it being equidistant, I would consider that one out. So the one that is the best description of a dilation is transformation that maps every point to a new point that is equidistant from a center line. A transformation that maps every point to a new point that is same distance and same direction. So our best descriptor. Question 8. The dilation with center at the origin of point C67 undergoes an enlargement to produce the image C'. Choose all possible coordinates of C'. There is only one correct answer. Select it, then select only. Okay, so this this image at 0.67, so this would have to be 6 and this would have to be 7, and this is C. Now they want an enlargement, and a dilation with an enlargement will take the distance from the center, since it's centered at the origin, so it will take this distance from C to the origin, and it will have a scale factor to produce that is greater than 1 to produce an enlargement. So it would have to be multiples of, for the Rx coordinate, it would have to be multiples of 6 and multiples of 7, but they would have to be multiplied by the same number. So let's go through this. C is 12 and 14. Oh, C', 12, 14. So 12, 14. And that would map C' right here. So this distance would have been doubled. If we look at our ratios from our x and our y, so C's x coordinate is 6. C prime's coordinate is 12. And I'm just thinking to myself, what scale factor would I have to multiply 6 by in order to have 12? And 6 times 2 would give me 12. So that has to be the same scale factor for the y-coordinate. So is 7 times 2 14? And yes, it is. So C prime, the first option at 12 and 14, would be correct because it is multiplied by a number greater than 1. So C prime with the coordinates at 6, 7, if you think back to yourself, okay, the scale factor has to be the same for both the x-coordinate and the y-coordinate. So if I think to myself, what would 6 have to be multiplied by in order to end up with 6? And that would be a 1. Since an enlargement, by definition, means a number greater than 1, this one is ruled out because the number is equal to 1. The scale factor equals 1. So C prime, 3, 4.5. Since an enlargement means it has to be bigger, I would ask myself, well, what would you have to multiply 6 by in order to end up with 3? And you would have to multiply 6 by 1/2 in order to end up with 3. So that 1/2 is not greater than 1. So this option is off the table. I'm not sure if the only is what we need to check. So let's check this next coordinate, 9. So if I ask myself, okay, what would I have to multiply 6 by in order to end up with 9? And I'm thinking, well, I don't know right off the top of my head. How can I find that? You would set up your scale factor, and we'd go compare C prime to C. So I'm only going to compare the x-coordinates right now. So 9 divided by 6, this would give us a scale factor of 1.5. So is 1.5 greater than 1? Yes. So let's check our y-coordinate. The y-coordinate was 10.5. So we're going to set up our scale factor again to check and see if it's the same for our y-coordinates. So the y-coordinate for C prime is 10.5 divided by C's y-coordinate, which was 7. So what is 10.5 divided by 7? That's 1.5. Since the scale factor is the same for both the x-coordinate and the y-coordinate, we do have an enlargement. Now the next one is C prime 24 and C coordinates of 24 and 28. So I'm going to ask myself, what would I have to multiply 6 by in order to end up with 24? And that would be 4. Or we can set up our ratio and compare C prime's coordinates to C's coordinates. So 24 divided by 6, and the y-coordinate was 28. For the y-coordinates, it would be 28 divided by 7. 24 divided by 6 is 4. and 28 divided by 7 is 4. Since the scale factor is greater than 1, and it is the same for both the x-coordinate ratio and the y-coordinate ratios, that is also an enlargement. Okay, a dilation with center at the origin of points B, 9, 3 produces the image B prime 3, 1. The dilation is therefore a blank with a scale factor of blank. Alright, so we started at 9 and we ended at B prime. So how can I find my scale factor? I think of it, if I can't remember which portion of does the point B go in the numerator or does the point B prime go in the numerator. This is how I think of it. I started with an original point, B. So I had my x-coordinate at B at 9, and I am multiplying it by something, and I'm ending with an x-coordinate of 3. So 9 times something has to give me 3. Well, 9 times k. In order to solve for k, I need to use the division property of equality. So I'm going to divide by 9 and divide by 9. So k is going to equal 3 divided by 9. Now, if I were to look back in at how I set it up, I'm going to remember that 3 was from my B prime, or my image, the resulting image, and 9 was from my original. So if I was going to write it in my notes, I'd say scale factor is equal to k equals the image, which is our vocab, and I would put in parentheses the resulting picture divided by preimage. Which is our original. So 3 divided by 9, that's how I would write it in my notes. So 3 divided by 9 is equal to 1/3. And I'm going to use how I set it up in my notes to check the y-coordinate scale factor. So the y-coordinate of our image or our resulting product is 1, and the y-coordinate of our original was 3. So our scale factor equals 1/3. They are the same. Since this is a number that is between 0, I'm going to ask myself, is this a number that is between 0 and 1? Or is it greater than 1? Since 1/3 is between 0 and 1, it is a reduction, and the scale factor is 1/3. So that's how I would go through those ones. And your quote or fact is going to be about, it is Secrets for Calm by the best-selling author of Instant Calm. So the first little tip is make magnanimity a habit. Indulge yourself by being generous. Help someone out. Perform an act of kindness. Offer a compliment. The person who will feel most uplifted by you having done so is you. So there is your little tip for feeling calm by Paul Wilson.